Okay, so this is our first trig identity that we're doing. And when you're doing an identity, which is right here, is that you're trying to get one side to look like the other side. So for example, you want to maybe see how you're going to use all those trig identities that we just learned to make that look like that. Okay, and there's some guidelines that you want to play by, just as a quality of life thing that it's going to walk you through how to make the best use of your time and efforts trying to get those sides equal to one another. So you always want to choose a side with more work to do. The reason being is that it's easier to shrink things down than to expand them out in trig identityville. You want to work with one side only, so you pick that side that has more to do and try and get it to this simpler looking side. If you're stuck, you can change everything, the sine and cosine, because that's what tangent, cotangent, secant, and cosecant are all made up of. So that's kind of like the basic building blocks. So if you have to break it down to the basic building blocks, that's a good way to go as well. And definitely try something. You just never know when the whole thing might fall apart. Okay. So the way that I'm going to do this, first one here, is that I'm going to rewrite it larger so I got some room to work. Okay, so looking at the rule here is that we want to work the side with more to do. And it looks like that left-hand side is going to be the one that seems like there's more to do. This is just sine squared. So there's not much really we can do with that. But it does look like we can work this left-hand side and maybe take a look at trying to get that thing equal to sine squared. Okay, so we separate them out. We choose the left-hand side to try and make it look like the right-hand side. So the first thing that I'm going to do is that, looking at this, there's a bunch of different ways that we can go, but what I'm going to do is that I'm going to be able to, since we're dividing by a single term, I can break this up into two separate fractions and go the secant theta over secant theta minus 1 over secant theta. Okay. And again, the reason why we can do that is that, say if I had 2 plus 3 over 7, okay, that'd be the same as going 2 sevens plus 3 sevens, okay? So that's what as long as you are dividing by a single term or a monomial like that, you can break them up into two different ways, okay? So I go over here and I'm like, all right, well, I know that's good news because I know that this is going to give me a 1 because it's divided by itself. And this 1 over secant, I know by definition is going to be cosine. So now I have 1 minus cosine squared theta, okay? So I'm looking at this thing, and this is where we have to be a little bit kind of, we have to be, how should I say, look at this in a clever fashion, okay? So what I'm going to do is that I'm going to go back to something that we learned that was going to be sine squared theta plus cosine squared theta equals 1, okay? And so anytime that we have 1 in a cosine squared or a sine squared, we know that we might be able to use this technique. Now, this is going on off to the side in your head. This is not part of the work or anything that we're showing right now. And so if I look at this and I say, okay, well, how can I rewrite this such that it looks like 1 minus cosine theta? And I can do that by subtracting the cosine theta from each side. And I'm just going to put cosine theta like that. And that is going to give me sine squared theta equals 1 minus cosine squared theta. Okay, now that's good news because this and this are the same. So since they are the same, I'm going to use substitution, and I'm just going to say that this 1 minus cosine squared theta is actually sine squared theta by definition. Okay, and now I'm happy because if I look, the left-hand side is balanced with the right-hand side. I have followed all the rules over here, or I didn't need to go ahead and do the last two, but I definitely did the first two, and that's our first identity there. So it's rewriting this in order to get this. Okay, so let's take a look at a few other examples, because really the only other way to get good at this is to see some different techniques, and so I'll meet you at the second example.